Page 8 of our final exam review for Algebra 2. We're going back to some SOHCAHTOA, some trig. And we have a 5, 12, 13 right triangle. And we're supposed to find the acute angles. Remember, acute angles are small angles. Their measurements are smaller than 90 degrees. And in all honesty, as you look here, you have a third angle of a right angle. Let's just focus on angle A. And with angle A, we're going to define our sides. Going directly across from angle A would be our opposite side. Going directly across from our right angle is our hypotenuse. And the side that's right next to angle A, this remaining side, is the adjacent side. Now, to find angle A, and that's what we're really being asked to do here, you have to go back to SOHCAHTOA. And the wonderful thing is you are free in this problem to pick any two sides. Sometimes kids might want to just choose the 5 and the 12 here, opposite and adjacent. Opposite and adjacent would be tangent. So the tangent of angle A would be the opposite side, that's 12, divided by the adjacent side. Now we want to get A alone, and that means we want to get rid of tangent. Tangent is not a number. It's not a number that we divide both sides by. It's a function that we have to eliminate. The way we can do that is to take an inverse tangent on both sides. And you don't have to write this step down. Obviously, our final exam is going to be multiple choice. But right now, your calculator is going to really come into play. You want to make sure you're on the degree mode. I pressed mode. I'm here. If you're not, hit your down arrow, put your cursor over degree, then hit enter. Well, be careful. You don't want to hit tangent, but second tangent. You see that -1 up there? Inverse tangent of 12/5. Hit enter. You'll get roughly about 67.4 degrees. And these wipe out. So that's the measure of angle A. Now, to find the measure of angle B, we could use trig. But I hope you remember from geometry that really what we're seeing is the two acute angles always add up to 90 degrees. The three angles must add up to 180. We already have a 90 right here. 180 minus 90 is 90 itself. So angle A and angle B must add up to 90 degrees. Right now, you know that angle A is 67.4. So just saving yourself a little bit of work, you could very quickly just type in 90 minus 67.4 and get angle B's measurement without even needing trig at all. You'd get 22.6 degrees. So either way, you'll wind up with these two measurements. For number 39, this should look familiar. This is what we have done most recently. I think you should notice that the 2 minus x and x minus 2 would cancel to a -1. X minus 4 and x plus 4 do not cancel out. So what do you have left? -1 times x minus 4 is up here. Down below we've got x plus 4 and x plus 3. It's important to note that very frequently you might even put a negative out in front of a fraction, or you could just leave a negative in the numerator. So all three answers that I'm writing right here are good, they're legitimate, and on a multiple choice test you'd have to be aware of any of these three. All right, moving down to number 40. Again, something that should look very, very familiar. It's what we've done most recently. We need to get a least common denominator. That means we need an x plus 1 from our first fraction. we also need an x from our second. And what are we missing? Well, from our first fraction, we're missing an x. From our second fraction, we're missing x plus 1. As we put this all together, we'll have x. Please watch out, we have to distribute the negative. We'll get minus 2x and then a minus 2. 1x minus 2x is actually a negative 1x. And then you're pretty much done. If you'd like to, you could also factor out a negative 1. That's always a good thing to do. You divide both of these by that negative 1. And again, if you'd like, you could even drop that negative just like we did up here up on top and just bring I should have said drop the 1 out. You could have just written that as the opposite of x plus 2 over x plus 1. So this would be a great answer. We'd even accept something like so. Any of those three. Take a look at number 41, last one on page 8. We have long division. In long division, it's been a while since we've done this. You're going to have one of these on your final. So let's see what we're going to do here. We're going to really play the matching game, as I like to say. You'd say, what times x would get me x cubed? And the answer is x squared. X squared is going to get multiplied to both of these. And I'll have x to the third plus 4x squared. Now, whenever you were dealing with this long division, it's very important to note that you would then subtract. You would change your signs. And once you do that, you're going to cancel out your first column. You will always cancel that out. 3 minus 4 is a negative 1. So we'll have negative 1x squared minus 6x. And then we repeat this process. Long division, in all truth, is going to be repeating the same basic step here of doing the matching game again. You'd say, what times x would get me negative 1x squared? And the answer would be negative 1x. We're going to distribute to both. We'll have negative 1x squared and then a negative 4x. After you've multiplied, then you're going to change both of these signs. That's how we really subtract. We add an opposite. These cancel out. Negative 6x plus 4x is negative 2x. Here we go, bringing down our last constant. That means we're almost done. Here's our last iteration. We're going to play the matching game one last time and say, what would I multiply to x to get negative 2x? The answer would be negative 2. So we will get negative 2x minus 8. Then, hopefully not too surprisingly, we will change our signs. And we will cancel this out. Negative 4 plus 8 is just a 4. This is our remainder, though. We'll take 4 over x plus 4. And it's at this point where we are done.